Hello everybody. We are back for day 3 of function notations, or not of functions in general. Thank you for being very patient with my absences. I do appreciate it, and I hope if you guys have any other questions on anything that we covered, whether I was here or not, you ask them, and you can stay after school or you can come during SOAR. All that stuff is awesome time to ask questions, as well as in class, of course. So today we're doing function notation and intercepts, the x and y intercepts. Okay, so let's go ahead and get started. Helpful hint, this stuff should be very familiar to you because a lot of the skills that you need is stuff that we've already done, like substitution and evaluating and stuff like that. So let's go ahead and get started. Vocab. Independent variable is a variable that provides input values of a function, aka the x values. The dependent variable is a variable that provides the output values of a function, the y values. So you need the x values to figure out what the y values are going to be. Okay? Now let's use function notation. But wait, what is function notation? Function notation is basically just a way of writing, just a way of noting a function. So this is what it looks like. Where'd it go? Oh, no, here it is. This is function notation. It's read f of x, so whenever we read it out loud, it's saying f of x. So it basically means this is a function of x. This is what, this x right here, this is the input value. So, and what you get when you put it in the function, that's the function of x. So when you put it in the function, this is what you're going to get. So it's always going to have it equal something. Okay? Basically what this whole thing, f of x, means is your y value. Okay? Your output value. So whatever f of x is equal to is your y value. So a lot of times you'll see y equals and f of x equals changed out because they mean the same thing. So they're interchangeable. Okay? So here is an example. Let's go ahead and try this. Basically a function, before we even start. To write a function, a lot of functions have equations. So when you see a function written out, it's mostly going to be in equation form. So we can easily find the input or the output if we need them. So you're just going to, so if you think about the function machine, you guys might have seen a function machine before. If not, ask me about it and I'll show you what it looks like in the class. It basically means, like, if I put this x in the equation, I'm going to get this y out. Or if I work backwards and I put this y in the equation, I'm going to get this x out. Okay? So we're going to be using a lot of equations, which is great because all of this is just substitution. Okay? So we're going to make a table for this function. We're actually going to get the x and y values for this equation, which is a function. Okay? So, and we're going to actually figure out what the range is for this function as well. So we make our table. That's the equation. So that's going to go in the middle. So that's where we're actually going to do all of our work. Here's where our x's are, and here are our x's, because they already told us what domain was. Yeah, I know, it's missing its braces. Shame. Don't do that on your quiz next class. Okay? But here are our x's. So basically what we're going to do is we're going to plug in these x values into the equation, and it's going to tell us what our y is equal to. So those are our y values. So this column is our y. Okay? So the equation is just 5 times x, so we go ahead and plug that in. 5 times 0, the y value for it is 0. 5 times 1, 5. 5 times 2, 10. And 5 times 3, 15. So here are our y values now for this function. So that's our range. The range is just 0, 5, 10, 15. Okay, if I'm going too fast, which I probably am, let's not lie, just go ahead and pause the video and give yourself some time to catch up, okay? Now you're going to go ahead and try this one on your own. You do it the exact same way. You're making a table, so set up your table the same way. They gave you the domain, and you're trying to find the y's, the range. Okay? So go ahead and do this one on your own. Pause video, and when you come back, we will go ahead on to the next section. Okay, moving on. So, tried this. You probably got the range. We'll go over this. We'll get the answers to this in class, okay? So now, we're going to do the table again. And when we have an equation, what happens is we get our coordinates, and because it's an equation, we can then create a continuous function. Sorry, I didn't know where I was going with that. But basically, they gave us our x values. We need to find the f of x values, which basically means we're finding the y values. Very good. So we go ahead and plug in the x into this equation, x plus 1, and we find our y values. So -1 plus 1 gives us 0. 0 plus 1 gives us 1. 1 plus 1 gives us 2. 2 plus 1 gives us 3. Okay? We go ahead and plot the points. And let's see if this plots without... No, it doesn't. Anyway, you plot the points, and then what would happen if it connected the points? Well, it makes a line. And then that's the actual graph of the equation. So meaning like it's more than just these x's that could be plugged in. A lot of different x's can be plugged in, getting a lot of different y's as well. So we get a line. Is this a relation or is it a function? Well, yeah, it's a relation because it's a group of ordered pairs. And actually, it is a function because it passes the vertical line test. So that's just where we're going with it. It's creating lines. All right, now here's another example. Very similar to what we did on the first page. But they gave us the range, and we had to find the domain. Okay? So we're going to be plugging these numbers in for the y value, the f of x value. So we're going to create our table. Here's where the x's go. Here's where the y's go. So -9, -8.5, -8, and -7. Yeah. And here's the equation. I just changed the f of x to a y, so it's very clear to know where it goes. You can keep it as f of x. It's totally fine. So that's what I'm plugging in. So -9 is going where the y is, and then I just need to solve for x. So it's just like solving an equation. So I'm going to add 8 to both sides, then divide both sides by 0.5 or multiply by 2. I end up getting -2. So I do that for each one. Okay, does create a little bit of work. Add 8 to both sides, so I get 0.5, divide by 0.5, I end up getting -1. Add 8 to both sides, so I get 0, divided by 0.5, I get 0. Add 8 to both sides, so I get 1, divided by 0.5, I get 2. So those are my x values. That's what I put in my table. Okay, now you're going to try these two on your own. They're a lot easier than that one. Go ahead and plug these in for the f of x, for the y, and you tell me what the x is. Okay, pause the video. When we come back, we'll move on. Okay, so hopefully you filled these in. We will go over these answers next class. Don't forget to write them as actual domains. I didn't do that on the example, so make sure you actually write, here's the domain, kind of stuff. Alright, new vocab words. X-intercepts are points where the function crosses the x-axis. Y-intercepts are points where the function crosses the y-axis. How are x and y-intercepts written? Well, basically, an x-intercept is some kind of x value, comma 0. So the y value is always 0 for an x-intercept. So it's only the x number that should be shown. And for y-intercept, it's the exact opposite. It's 0 for the x, but there's a number for the y. So it's only a y coordinate that should be shown. Okay? Now, x-intercepts have lots and lots of different names, and we will use them throughout the entire year. So some of the different names are, they're zeros, they are solutions, and they are intercepts. Wait, I already said that. That's not the right one. Oh, roots. Please write that in. Roots is the other one. Not intercept, roots. So cross that out. Roots is the other word. Okay? You're going to hear 0 a lot. You probably already heard 0 in that SmartArticle assessment. Maybe? Maybe not. 0 is just an x-intercept, not y at all. None of these mean y-intercept. Y-intercept only has one name, and it's Y-intercept. X-intercept has lots of different names. So, example, given the following graph, what are the intercepts? Is the graph a function? So, we need to know the x-intercept, which is crossing right here at -7. So, -7 comma 0. And the y-intercept is crossing right here at 6. So, 0 comma 6. That's your y-intercept. They ask what are the zeros? -7 comma 0 is my 0. Okay? And is it a function? Yeah, because it passes the vertical line test. Okay? So you're going to go ahead and try this one on your own. We're just trying to find the intercepts, okay? So give yourself a second, write them down, pause the video if you need to. I'm going to come back. We'll go over these next class for sure on the board. But yeah, let's go on to the next example. Given this graph, what are the zeros, and is it a function? Remember, zeros just means x-intercept, so that's all it's asking for. What is the x-intercept? Well, the x-intercept is right here at 5, so 5 comma 0 is my 0. Okay? And is it a function? Well, pass the vertical line test, so yes. This one, try on your own, it's asking what are the zeros. So, when they're asking for zeros, remember you're looking for x-intercepts and all the x-intercepts. Anywhere it's crossing x-intercept. And this one kind of looks a little fuzzy, so round it to the nearest integer. Integer is the word I'm saying. Okay? Round your zeros to the nearest integer. Okay? And that's it for the video, so we'll go over this one and all the other try on your own next class. Have any questions? Write them down. Other than that, see you later.